Hi, Manahil.
Hi, ma'am.
How are you today?
I'm good.
Perfect. Okay, let me just start sharing right away so that we can, finish what we have to do today. So, did you do the homework or the activity that Sir gave you?
No, ma'am, I didn't get time to do it. There's so many projects and tests in school.
Okay, no problem. Okay, let me just start sharing and then we'll work it together. So, can you see my screen?
Yes, ma'am.
Perfect. So, what do you recall or do you know anything about the laws of exponents?
Yes,
Okay, which rule is your favorite?
the the rule that's it's the first rule that normally asks the for example, if it's two, a to the power of two
Mm-hmm.
times a to the power of three, then you add those two exponents together.
Okay, perfect. Do you remember the one whereby you are dividing the same basis?
Yes, ma'am.
Okay, what do we do if we are dividing the same basis but different exponents?
Sorry.
So let's say we have a divided by, okay, a to the power of 1 divided by a to the power of 5. Do you know this rule?
Yes, ma'am. You minus the exponents.
Perfect. So let me just confirm if you understand all of them, then we'll dive into the homework. So do you remember this one?
Yes, ma'am.
Okay, so what is going to be the final or last one if we are dealing with this with this rule?
Is it a to the power of x and b to the power of x?
Yes, it is correct. A to the power of x and b to the power of x. I think you understand the rules. So okay, let me do this one, the last one. What is going to be the answer for this one? If you are transferring it or transporting it to be a rule. Do you recall this one?
No, ma'am.
Okay, so when you're dealing with this one, what you're gonna do, since there is a negative, you treat this negative as a divide. So what we're gonna have is 1 over a, and the exponent follows the x. So this negative is gonna be treated as a divide. So it's gonna be 1 over ax. So if it's something like let me say 2 to the power of negative 1, means it's going to be 1 over, because of the negative, it's 1 over 2 to the power of 1, which can be written as 1 over 2. So do you know the other one? Yeah, the zero exponential rule. So it's like a to the power of 0 equal to.
I know the answer. It's going to be zero.
Okay. Okay. So, okay, do you have your calculator next to you?
Yes,
Okay, punch 2 to the power of 0. What do you get?
it's one.
Okay, punch 4 to the power of 0.
I got one.
Perfect. So, each and every number or letter or an a that is to the power of 0 is equal to 1. So if you are given, you have 1 multiplied by, let me not say, okay, yeah, let me say b to the power of 2. We can change this one and write it as b to the power of 0, because b to the power of 0 is the same as 1. So it's going to be b to the power of 0 multiplied by b to the power of 2, and then you work out the exponents. Do you understand that?
Yes, ma'am.
Perfect. So let me see the last one, which also looks okay. So now we have, oh, my x is not good in. So we have a to the power of fraction x over y. Do you know how do you transfer this?
Is it going to be 8 divided by xy?
Mm-mm. No, it's not going to be like that. It's going to be a rooted one. And whenever you introduce the root, you take this as it is and you write it here. And the below, or what do we call a denominator and the numerator? I think the below one is the
Denominator.
perfect. Thank you so much. And you take the denominator, you write it on the on the yeah, there. So okay, let me just dive into the thingy, but this one year fraction is not really important for this lesson today. So today we're gonna be looking at example 3 that says simplify the following and leave your answer in exponential form. So now we have to make sure that our answer is on exponential form. If it is 2 to the power of 5, do not calculate it and be like, okay, 2 to the power of 5 is equal to what, because they are telling us we have to make sure that our answer. Okay, sorry, I'm back. Without wasting our time, let me, yeah. Okay. Am I audible and is the screen visible on your side? Manahil?
No, ma'am.
Okay, let me see. Let me just go to the thingy and see if you can see. Can you see now?
Yes, ma'am.
I'm so sorry. I don't know why it's kicking me out. So let me share, hoping that it won't disconnect again. Running back to the thingy. Okay. Am I audible?
Yes, ma'am.
Perfect. So, since we have this 2 to the power of 3 over 2 to the power of 8, we can also write it as 2 to the power of 3, and we include this type of divide and be like 2 to the power of 8. Now it's making it easy for us to see that we are having two similar bases. So since we have two similar bases, means the rule says that we can subtract these two. So, excuse me, what we're gonna do, we're gonna write our 2 to the power of 3 minus 8. So on your side, what is 3 to the 3 minus 8?
-5.
Perfect. So you write your 2 to the power of -5. So we check this and go up there to the rule. There is a rule that says if you have something saying that it's negative, we can write it as 1 over something something, which is this one. So it's the negative rule. So based on the negative rule, we can write our answer as 1 over 2, and we keep the 5, so it's gonna be to the power of 5. Do you understand? Or another example?
I understand, ma'am.
Okay, so let me give you one on your side so that we can pass very fast. So let's say we have 3 over 3 to the power of 4 to the power of 7. Try this one.
Ma'am, I got 3 to the power of -3.
-3. And what was your final answer?
1 over 3 to the power of 3.
Okay, correct. So let me do the second one with you. So we have B that says x to the power of 2 over x to the power of 8. So similar with the numbers 2 over 2, x over x are regarded as similar bases. So what's going to happen here is x to the power of 2. So you copy your x to the power of 2, divide by, let me just include the line there, x to the power of 2, x to the power of 8. Let me go confirm, and yeah, it's correct. So what we're gonna have now, since we have the same basis, so let me just write it as x to the power of 2 divided by x to the power of 8 equal to, we see that we have the same basis, we write 1. We are dividing, meaning that we're going to subtract these two exponents. And we're gonna start with the 2 because it's the first one on our thingy. So it's gonna be 2 minus 8. So what is 2 minus 8?
-6.
-6. So what's gonna happen here? You're gonna include that rule that says a to the power of -1 equal to 1 over 8. So what you're gonna do is you're gonna be like 1 over, since we treat the negative as divide, so it's 1 over x, and our exponent there is 6. So you write your 1 over x to the power of 6. Are you clear with this one?
Yes, ma'am.
Okay, let me give you one so that I can be totally sure. So let's say we have a to the power of, okay, let me say 40 over a to the power of 40 minus, okay. Okay. Let me just write it down here. So let's say we have a to the power of 40 over a to the power of 60. You can try this out.
Ma'am, I got 1 over a to the power of negative 20.
Okay, negative 20, just like this.
No, sorry. I got 1 over a to the power of 20.
Perfect. Perfect. Very perfect. Very nice. Very nice. Okay. So let me give you one again and then we'll pass. So let's say we have, okay, let me say D. Okay. So let's say we have D to the power of 4, or yeah, over D to the power of 5. I'm thinking of including a negative, but let's work this out and see what happens.
I got 1 over d to the power of 1.
So you can just write it as like this, 1 over D. So let me say, okay. So on this one, let's say now we have D to the power of negative 4 divided by D to the power of 5. Let's try this one out.
I got 1 over d to the power of 9.
Perfect. Very good. All right. So I think you are perfectly good with this one. So the third one, okay, they're including in multiply by now. So let me just do. So what you see, we have 2 to the power of 3 times 3 to the power of 12. 2 to the power of 3 times 3, excuse me, 12. So yeah, over the next one, 2 to the power of 8 times 3 to the power of 8. So we have 2 to the power of 8 times 2, 3 to the power of 8. So now we have to do, or we apply the like terms rules. Do you see any like terms in those in the thingy?
The like terms are 2 2 to the power of 3
Yes.
and 3 to the power of 12 and the 8 2 to the power of 8 and 3 to the power of 8.
Okay, now let's group them. Which like term is grouping which with which one?
The 2 to the power of 3 is going to deal with the 2 to the power of 8, and the
Okay.
3 to the power of 12 is going to deal with 3 to the power of 8.
Perfect. So what you're gonna do now is that we have this and this as like terms. So we can just write them as 3, or we can treat them as 2 to the power of 3 and 2 to the power of 8 multiplied by 3 to the power of 12 over 3 to the power of 8. You can just treat them like this. I'm not so sure if it's a step that is supposed to be written, but you can treat them like this. And then since we can see now these two are dividing, the rule says if similar bases are dividing, we add the exponents. So we're gonna have 2 to the power of 3 minus 8, and we multiply by 3 to the power of 12 minus the 8. So what is going to be 3 minus 8?
It's going to be -5.
-5. Perfect. And excuse me, what is going to be 12 minus 8?
4.
Perfect. So you write your 3 to the power of 4. So now, since we have this rule, we can't leave it as it is. We have this rule whereby we have to treat the negative as a divide. So now we're going to include the 1/2 to the power of 5 multiplied by 3 to the power of 4. And that's your answer. Okay, wait. Okay. And then since, yeah, we can multiply these two and we can get something like 3 to the power of 4 over 2 to the power of 5. Since if we multiply this and this, the 1 is going to multiply with the 3 to the power of 4. So the 3 is going to climb on top. Are we clear?
Yes.
Perfect. So do you want another example or I should give you one to work out?
I think you should give me one to work out.
Okay, let me see. Okay. Okay, let me just write it up here. Which one? 3 to the power of 4 times 4 to the power of 3 over 3 to the power of, okay, 5. No, 5 is not looking good. Multiply by 4 to the power of 6. Okay. To the power of 0. Okay, yeah, you can try that one out.
Ma'am, I got 3 to I got 3 to the power of -1 and times 4 to the power of 2.
4 to the power of 2. Okay. So, when we're coming to to the 4 part, did you say 3 minus 0?
No, um I said 3 minus 1.
Okay, because here it's 0 on top of 4. The exponent next on top of 4 is 0. You see, I think I understand what you're saying. Because since 4 to the power of 0, it can be written as 1. But now we can't change it because we want to deal with this one in a simplest manner. So what you're supposed to do, since you have the same basis, you just subtract the exponents. So it's going to be 3 minus the 0, which is going to be 3. Are we clear?
Yes, ma'am.
Perfect. So on top here, you're gonna have to the power of 3. So it's 3 negative 1, or 3 to the power of negative 1 multiplied by 4 to the power of 3. So can we do something to this 3 to the power of negative 1?
We can write them as a fraction.
Okay, how
As
can you?
1 over 3 to 3.
Perfect. So it's 1 over 3 multiplied by? So we're
4,
supposed to...
4 to the power of 3 over 1.
Okay, perfect. Yes. And then what's going to be your last or final answer?
4 to the power of 3 over 3.
4 to the power of 3 divided by 3. Correct. So, all right, number D or letter D, but x to the power of 4, y to the power of 2, divided by x, y to the power of 3. So let me just write it down here because I think up here we don't have a lot of space. So it's x to the power of 4, x to the power of y. Okay. Oh my God, my thing is not coming out now. Let me remove it and open it again. Perfect, it's back. So we have x to the power of 4, y to the power of 2. So it's x to the power of 4, y to the power of 2 divided by x. X, y to the power of 3. So now we look at the like terms again. So we see if we have like terms. So do you think there are like terms there, and which like term is pairing which one?
The x to the power of 4 is going to deal with the x, and the y to the power of 2 is going to deal with the y to the power of 3.
Perfect. So how you going to write it? Since we are dividing, we're gonna keep the x to the power of 4, and then since on top of the x there is an imaginary 1, we're gonna say 4 minus the imaginary 1, and then we write the y, which is gonna be multiplied by y to the power of 2 minus, and down here we can see that we have a 3. We write our 3. So this is how we carry on with our thingy. What is 4 minus 1?
X to the power of 3.
X to the power of 3. And the next one?
Y equals -1.
Okay, don't include equal to.
To the power of -1.
Perfect. So it's going to be to the power of -1. Can we do something there?
We don't have to write the -1.
Perfect. How can we write it?
As a fraction.
Okay. Let's carry on.
So we can write 1 over x to the power of 3 and y over 1.
Okay. So, Jong, this negative, this one, okay? This one, we're supposed to write it as 1 over this one. So now we treat this as an over. So it's gonna be 1 over y, right? But if it's going to be y to the power of -2, the negative 2 is gonna come to this one, and then we have a 1 over y to the power of 2. Are you certain about that one?
Yes, ma'am.
Okay, so for this one, what is going to be our final answer is that we're gonna have 1 over y. Since we don't have anything, or we only have 1, we can just write it as 1 over y. And afterwards, we can just divide this one by 1, and then we cross multiply. No, sorry. And then we multiply, and we're gonna have x to the power of 2 divided by y, which is the final answer there. Are we clear?
Yes.
Okay, don't cross multiply. Sorry about this, because we don't have a working, we don't have an equal sign. So, okay, let's see the next one. Okay, it's E. Negative 6x to the power of 3, y to the power of 2. So let me clear my space here. So, okay, it's negative 6x to the power of 3, y to the power of 2 over negative 2x y to the power of 3. So here we can just simply divide. So what is negative 6 divided by negative 2? Manahil?
-8.
Negative? You said negative 8.
Yes.
Okay, we are dividing this, the negative 6 and the negative 2. So you're just gonna say negative 6 divided by negative 2.
3.
Perfect. So you're gonna write your 3. And now we have the x, which is going to be x to the power of 3. And we have an x down here. So can we do something with the x? Because now we're dealing with the Vatican with the divide, means we're gonna minus the 3
-.
and the, yes. So we're gonna say 3x to the power of 3 minus 1. And then we have a y to the power of 2. We write our y to the power of 2 minus our 2. So what is 3 minus 1?
2.
Perfect. So you're gonna write your 3x to the power of 2. And what is going to be 2 minus 2?
0.
0. Perfect. So you're gonna have your to the power of 0 there. And we can also write it as 3x to the power of 2. Do you remember the rule that deals with y to the power of 0?
It's going to become a 1.
Perfect. So you're going to multiply the 3x to the power of 2 by 1, which is going to give you, what is 3x to the power of 2 times 1?
3x to the power of 2.
Perfect. So your final answer is going to be 3x to the power of 2. We are done there. So let me see. Do you want an example, or you want another and to work on your side?
You can give me one to solve.
Okay, let me just think. Okay. So let's say, okay, wait, okay. Let's say 6 over 3. both negatives. You can try this one.
Which one?
You can try this. I kind of changed this, so you can try this one. So it's negative 6x to the power of 3, y to the power of 2, negative 3x to the power of imaginary 1, y to the power of 2. Are you winning?
Yes, ma'am.
Okay.
Ma'am, I got 2 times x to the power of 2 times 1.
2x to the power of 2 and 1. Like this.
Yes.
Okay, so what's going to be your final?
2x to the power of 2.
2x to the power of 2. Perfect. So let's see. But in 9. Okay, let me just write this down because I think I'm gonna forget. So it's 9x, open bracket, y, which is negative, that is inside bracket, x to the power of 2, y, yeah, x 3. And it's not visible enough. I'm also gonna need this part. Okay. So let's see. it. All right. So it's x to the power of 3. So now what you can do is you write something like this. So let me see something. Okay, it's to the power of 3. Sorry about this. So what you're gonna do is, do you know that we can write this 3 times? So we can say 9 into negative y, negative y, negative y, x squared over 12 yx to the power of 2. Are you following?
Yes.
Okay, perfect. So Now we can say this multiplied by this, which is going to give us positive y to the power of 2. But the moment we multiply the positive, okay, let me just write it down. So 9 into positive y to the power of 2 multiplied by negative y x to the power of 2 over 12y x to the power of 2. So we're gonna again multiply these two because they are like terms, because it's an y, it's a y, and it's a y. So when you say y to the power of 2 multiplied by negative x, it's going to change the sign and it's gonna be a negative y. So we're gonna have our 9 into negative y to the power of 3, close bracket, x to the power of 2. And this is going to be all over, oh, my space is finished, 12y x squared. Are you winning? Like,
Yes.
you follow it? Okay, perfect. So now what's left is we open the brackets. We're gonna say 9 multiply by y to the power of 3. So let me just write it here. We're gonna have 9, which is negative, y to the power of 3, x to the power of 2, all over 12x to the power of 2. So let me take this to the below so we can work it out. So it's 9 y3x2, 9y3x2, 9y3x2 over 12x2. So now we can look for what again? I think they are called the factors of 12, factors of 3. And if we say all these, let's say 9 divided by 3 over 12 divided by 3. What do you get when you divide 9 by 3?
3.
3. And what do you get when you divide 12 by 3?
4.
4. So now you're gonna go down with your answer using the 3 over 4. So it's gonna be 3y to the power of 3, x to the power of 2 over 4 to the power of x. Yeah, sorry, x to the power of 2. So that's going to be your final answer. Let me see something. Okay. I think these two are similar. They can cancel and we're gonna remain with, yeah, with 3y to the power of 3 over 4. Did you see why I cancelled the 2?
No.
Okay, so let me just write it aside. So we had 3y to the power of 2, x to the power of 2 over 4 to the power of x. So now if we look at these, there is nothing similar about them, you see. But if we look at these ones, we can see that they are both similar. So if we say we are dividing them, let me see, it's going to be x to the power of 2 minus 2, which is going to be 0. Do you understand?
Yes, ma'am.
Okay, so let me give you one so that I can make sure that you indeed understand. Let me check my time. Okay, 4 minutes. All right, how can I write this? Okay, let me just change this thing and this one, and let me say Let's say we have 12 up here and we have 9 down here. Please try this one.
Which one?
The one I circled there. So you're trying 12 y to the power of 3, x to the power of 2, all over 9, x to the power of 2. Are you winning?
Yes.
Okay.
Ma'am, I got 12y to the power of 3 divided by a.
Okay, let me see. Divided by a.
Yes.
Oh, you are treating this as an a. So it was a 9, but let me see. I'll calculate on my side. So you said you got 12. Why what?
I got 12y to the power of 3 divided by a.
Okay, so let me cancel this part. And you say divided by a. So I think, let me just calculate it on my side and see if we were using a, what were we going to get? Oh, and my time is up. So let me say 12y 3x squared over 8 to the power. Okay. So we're gonna have 12 and all right. Yeah, it is correct. So thank you so much. We're supposed to cut it now because there's another session. So thank you so much for the wonderful session. Can you, okay, I'll send something. If you have time, you can try. And then, yeah, this one. Can you please do a screenshot? Are you done?
Yes.
Okay, perfect. Thank you so much. Have a wonderful night.